So, welcome to the BioID workshop. What we did in this workshop is we're actually creating a biometric ID that's going to look at landmarks on the face and determine the age and gender of the person. And it's also going to give a unique biometric random sequenced ID that automatically keeps changing. So, what we have here is we are importing a bunch of different libraries. I'm going to go over them real quick. So we're going to import OpenCV. We're also going to import MediaPipe. And then from MediaPipe, we're going to look at task. And inside that, we're going to import Python. And then from the MediaPipe task Python library or folders or directory, we're actually going to import Vision. Then we're going to import NumPy. We're also going to import hashlib, and we're also going to import TensorFlow. We can also, there's another way of doing this where we're using DeepFace, and you can actually from DeepFace import DeepFace, which is another way of actually doing this. So first we're going to start off with the setup here. What we have for the setup is we have our base option. And what we're doing is we're looking at Python and we're looking at this function base option, okay? This variable that is inside this model Python. And then basically it's a task API. Basically what we're doing is we're taking this base options and we're setting our model asset path to face landmarks. So basically, remember how I said we were looking at landmark points on the face. So we're actually going to take face landmarks.task, and that's what we're going to use as what our model is going to assess, basically. Then we have options, and we're going to look into vision, the vision model, and from the vision model, we're actually going to do face landmark options, and we're going to call this variable face landmark options. And what we're going to do here is we have a bunch of different functions. So we have our base options, which is going to be connected to our base options. We have number of faces, which we're only detecting one face. We have an output face blend shapes, which we're not going to need. So we're going to change that instead of true, we're going to change it to false. And then output facial transformation matrix, which we don't really want a matrix. So we're going to also leave that as false as well. From there, we're going to actually now set up our face landmarker variable. What we're going to do is we're going to use vision face landmarker, and we're going to actually do create from options. And from options, that's what we're doing here. So we're putting this inside of our create from options function that's connected to face landmarker in the vision model. Next, we're going to start using a little bit of a different type of thing. So we are actually going to use a model called Cafe, or Cafe, and you're also going to use a deep neural network model to do the age and gender. So we actually are going to load the age and gender models. And how we did that is basically we have basically over here, as you can see, we have actually a couple different things, but we're looking at deploy age, and we have AgeNet cafe model, right? Or cafe model. And what we're going to do is we're going to use those two things as what we're going to read in. And then for the gender, we're going to read the other two things here that are on the side here. And then obviously this is created by our landmark task. So our landmark task that was created right here is what we're reading here, face landmark task. So we're actually loading that in, if you will. So what we're going to do is we're going to load our age and gender models, and we're going to say AgeNet and GenderNet. We're going to do OpenCV, look at the deep neural network model, read net from cafe model, and this function is going to read both of these files. It's going to read the proto text and also the cafe model for both age and gender. Then we're going to set a path which is going to look at the video capture, which is basically activating our webcam. And then we have our classification for age and gender. We're making a list, basically an array of different age ranges and different, and our two different genders. You can add a age buffer or a gender buffer. This can actually buffer the ages. So let's say that it's in between. It's like, say, in between an age or in between gender. It's not too short. We can actually buffer it out to actually be a little bit more clear and a little bit more clean if you wanted to. We're going to generate the BioID. This is going to be a defined function that we're going to take in the landmarks, and the landmark flat is going to use a NumPy array, basically taking those landmarks and flattening them out. This is a method. And then what we're doing is we're actually going to take that BioID and we're going to use hashlib, and we're going to use this function here, which is going to utilize the landmark flat, this variable here, and we're going to convert it to bytes, and then we're going to hex digest that into a hexadecimal and look at the 16th bit. And then we're going to return the BioID. So we're basically saying, hey, create a random sequence of numbers and symbols and make it 16 long. And we're going to return the BioID. This right here, this thing that's commented out, you can actually make another function for cropping out the face. So instead of taking the entire frame, which is what we're doing, which makes this not accurate that much, we can actually crop out just our face portion from the frame and focus in on just our face. This takes away looking at the entire frame and actually makes this program a little bit more accurate. And then while true, like I said, because we're taking video, we're going to have a while loop that's a continuous while loop. We're going to use passes, which is we're going to use passes, how many passes through the frame, and then we're going to read that. So we're actually going to read the frames, or read what we're looking at from the camera, and put it as a frame and it passes. If not passes, it's going to break. So if there is nothing to read, this while loop's just going to break. Now we're going to convert the frame from RGB for media pipe. So we're actually going to take the original BGR and convert it to RGB to use for media pipe. And then MP mapping image is actually media pipe image. And then we have MP, which is media pipe, and we're going to have this class image. And what we're going to do is we're going to look at image format, and we're going to take that, we're going to change the format of the image to be sRGB, which is 1 byte for R, then 1 byte for G, and then 1 byte for B. And that's kind of what we're doing. We're splitting it out among our RGB type of image. Then we're going to take that data, which is actually going to be, we're going to set the data to the RGB. We're going to set it to red, green, blue instead of blue, green, red, and that's what our data is going to look at, that coloration. Then, or the frames in that coloration, I should say. Then we're going to process the frame to detect the face landmarks. So what we're going to do is we're going to have results. We're going to look at the face landmarker, and we're going to do detect, and we're going to detect these face landmarks from the media pipe image, okay? And if the results of the face landmarks, and if this is true, so we're looking at if landmarks is part of the results, then for each landmark in results of face landmarks, we're going to collect the landmark coordinates, meaning we're basically going to collect X, Y, and Z for every landmark in face landmarks. I know that's kind of confusing. It'll make sense once I run this, and you'll start to see what this graphing type looks like. Then we're going to convert and normalize the coordinates to pixel coordinates. So we're actually going to take those coordinates, those landmark coordinates, and actually make them pixel coordinates by these two lines here. So you have height, width, and then blank out, and then we're going to, equals the frame shape, and then we have face landmarks and the pixels, and we're going to change and convert that in this line here to pixels. Like I said, you can also do the cropped, and this crops the frame and landmark pixels. If you were to use the actual cropped function, you can actually use this line here. Then you have draw landmarks on the face. We're actually going to draw the landmarks on the face. So for every X, Y in landmarks pixels, we're actually going to do a circle, and we're going to draw a circle. And what we're doing is we're going to take the frame, the X, Y, we're going to have 1, which is going to be the size, we have the coloration, and we have the thickness. And then we're going to generate and display the BioID. So BioID, we're going to it's going to be a function of generate BioID. This function right here comes back from this function. So we're actually going to utilize that defined function that we had. So we're going to generate the BioID based off the landmarks that are given. And then we're going to put text, basically just saying that the frame is BioID. And then we have the BioID. So we're actually going to we're going to put a text on the frame, on the video frame, called BioID, and it's going to show the BioID right next to right next to it. And we have the size 10 by 30. We have the location 10 by 30. We have the font. We also have the size. We have the coloration, and we have the thickness of how bold, or in font, technically thickness means bold, how bold we want the text to be. We're going to highlight key facial features. So we have the left eye, the right eye, nose, mouth, things like that. And how to do that is we look at the landmarks pixels, and we're actually going to look at an array, basically. So we're looking at 33 to 133 for the left eye. We're looking at the right eye, 362 to 462. Now, how do I find all these numbers? All these numbers are actually in MediaPipe. So when you look at MediaPipe imaging or MediaPipe landmarking, you can actually define the landmarks you're looking at. Then we're going to draw polylines around key features, meaning these polylines are basically connecting lines that are going to connect from one thing to another thing, if that makes sense. So we're actually going to draw polylines around key features. So we're actually, around these key features, let's say the left eye, the right eye, the nose, the mouth, we're actually going to draw some lines around that. And is closed as a parameter. We're going to have the one that's not closed is going to be nose. Our nose is not going to be closed. We're going to have basically saying, can your nose be closed? So unlike your mouth, it could be opened, it could be closed, and your eyes can obviously open and close. Your nose cannot open and close, and that's what this is closed is for. And then you have coloration for every single thing, and then you have thickness. Now we're going to process the face for age and gender classification. There's a line here that you can do if you were to use crop. You can say if cropped.shape, and you can use this line, and you can also do cropped.shape 1 is greater than 0. So you can do this line if you wanted to. If you were to use deep face, you can also do this. So using deep face for age and gender analysis, you could do this. We have face blob, and what we're going to do is we're going to look at OpenCV DNA, the deep neural network, and we're going to do blob from image. And what we're going to do is basically we're going to get a portion, right? We're going to get from this frame, we're going to get a portion of what we're trying to focus on. So let's say we're just trying to get the face, right? So what we're going to do is we have parameters here. Basically what this has is you're going to have the image, you're going to have a scale factor, size, mean, swap RB, crop, things like that. You even can do depth, right? So if you had depth, but what we are going to do is we're only going to use the first few. So we have frame, this is the scale factor, we have the size that we're looking at, we also have the mean, this is the mean, right, that we're going to be focusing on. So it's anywhere from 104 to 123, but 117 is the middle of where we're trying to get. And then we have swap RB, and we also have crop. We're not going to crop and we're not going to swap RB. We're going to leave those false. We don't want them to be true. Then we're going to have age net, and what we got here is for age net, what we have is this is going to be, we're going to set the input to the face blob. We're also going to have gender net set input to face blob as well. So we're actually going to use this variable that's looking at a portion of this image, which is only focused on the portion where our face is, and we're going to check the age and gender from it. Then we're going to predict the age and gender, so we're actually going to use a prediction based off of our gender net and age net. We're actually going to use a method called forward, and what we're going to do is this forward method is actually going to forward the prediction of, or forward our so-called predictive ability or capability of this model to actually predict what our age is and what our gender is based off of facial features. And that's kind of what these lines are doing right here. And then you also have age is going to be set to the age list, gender is going to be set to the gender list, and then we have obviously this argument max and an argument max for the predictions for both gender and age. You could also do something where you actually filter by, so everything commented here are other ways of doing this. So you could filter based on confidence, which this is how you would do that. If you wanted to add predictions to buffers, you can add that as well. You can also smooth predictions using a moving average. So you can actually smooth the predictions if you wanted to be a little bit more accurate by using a moving average. So this average kind of changes and varies as the program runs. But the next thing I wanted to show is these two things. We're just going to put text for age and gender, and then it's going to just show the age and gender. And like I said before, this is very similar to what we did for the BioID, except we did change the coloration and the thickness. Then we have an exception if you really wanted to. This is for if you were to use deepface, obviously just by this print statement, deepface analysis error. So we have an exception for deepface if you were to use it. This is just going to show you the actual frame, or yeah, a separate frame that's going to pop up. Then if CV wait, this is the escape key, it'll break, and then you're going to do path release and destroy all windows. So let's run through it and let me show you kind of what this program is going to be doing. And if we put it all together, takes a little while. So here you go. This is kind of what you get. So as you can see, those little points and those little landmark points, those are key areas. And then you see those polylines that are connecting the little areas around the main features. And as you can see, we have a bunch of different lines, and these are all those little points that these lines are going from and to are actually around are actually basically creating a mesh, if you will. So they're actually creating a mesh, and this is actually using MediaPipe face landmarks. And we're just using it, and you can see basically if I move, the landmarks will move. As you can see, technically the gender is kind of accurate. It's pretty accurate. That bio ID keeps changing. It's a random sequence of numbers and letters and things like that. And it's a 16, should be 16 long. And then you have age, which is saying that I'm around 60 to 100, which is not accurate at all. That's kind of misleading. But that's where those other things that I commented out are very, very good. Since we're taking the entire frame here into account, that's why we're not actually getting the age. This age is very well off. So, and then if you press the escape key, it kind of shuts it off. So that is pretty much it for the BioID and how the BioID works. And I definitely suggest trying these, trying deep face and trying cropping out your face and only focusing on that portion. It actually probably is going to change the results for sure. It will change the results. So thank you for coming to the BioID workshop.